Okay, entonces, you understand very well que this is a quadratic equation and this is incomplete, right? And when it's incompleted, the solution is easier using a square root method. Square root method is apply square root. You know that a square and square root cancel out each other. And square root 25 is 5, but don't forget plus and minus. This is the key idea that you never forgot when you apply square root method. The answer is two solutions. It's obvious. Normally, the most common situation is that the quadratic equation have two solutions. Sometimes no, but the most common, 99% of the time, we have two solutions, 5 and negative 5. The reason is because it's a parabola, no? The parabola looks like that. So one geometric interpretation is the graph of the quadratic is a parabola. En phi in 25 equal 25. Suppose this line is y equal 25. We have two intersecting, is phi positive and phi negative. This is the idea behind this. It's important to understand the interpretation of the thing. That is a reason that in the systematic procedure, you put plus and minus two solutions. Clear? Yes or no?
Yes.
Number one. Number two is similar. This is k squared equal 11. You apply square root both sides. Unfortunately, 11 is not a perfect square number like a 25. But it's prime, so we cannot simplify more, and you put plus or minus radical 11. So we have two solutions, k equal radical 11 and k equal minus radical 11. Okay, not bad. Just in case, the test file I say in the last class. Okay, see if there are contradictions, you take, because I am doing too fast now, and maybe I don't pay attention very well. Because there are coincidences or no? Elisa, are you there, Elisa? You always help me. Elisa?
Yes, Professor, I'm here.
There are coincidences, or I am making a mistake?
I don't know. I didn't check yet.
Okay. But the test
Sorry.
file I sent last time. I tried.
Yes, I saw Friday or Friday that night or Saturday in the morning. I saw.
Yes, I know. Even there are students, Emily, saying, Emily is saying, Mister, okay? Because I don't make a mistake. It's not test number 4. Test number 4 is history. I grade, yeah. There are one case
No,
pending.
Professor, she's talking
Uh-huh.
about test number 5. On test number 5 that you sent us last weekend, it shows, like, when you open it up, it says test 4 on the front of it. So she's trying to clarify if we're supposed to do that one or if there's another one being sent.
So you say that the test I sent before is wrong.
Yeah, it says test 4 on there.
Okay. But just now, don't worry. The confirmation is now today. When I send the video, I resend again the true test because I have more time.
Okay, okay, got it.
By the way, this test is short. Only have 10 questions, not 20. Okay? Okay, let's continue then.
You said test 4 only has 10 questions?
No, test 4 is history. I don't want
Yeah,
to.
yeah, it's done.
Test 5 have only 10 questions.
Beautiful. Thank you.
Perfect.
All right.
Okay, number 3 now is 16b squared equal 81. Okay, you isolate the variable b squared is equal 81 divided by 16. I move 16 is multiplying here, and the other side dividing. And now apply square root both sides. B alone is equal, don't forget plus or minus, and you separate square root 81 que es 9, and square root 16 que es 4. 9 over 4. Entonces es 9 over 4. We have the solution, no? As frequently happen in the quadratic equation. One solution positive, one solution negative, not necessarily the same value. In this case, yes, because this is incompleted, it's reduced quadratic equation. So you need to be aware when you have reduced or when completed quadratic equation, the shortcut to do that is super fast. Okay, now, okay, this is the problem says solving the quadratic equation by using the square root property. The square root method, square root property is the same, it's synonym. Okay, cool. Okay, now number 4 is weird. It's negative 9 m squared equal 81. Okay, it's similar. You isolate the variable n squared divided by negative 9 both sides, negative 9, negative 9. Is equal positive divided by negative, negative, negative 9, no? Because 8 times 8 is 81. Now, in this moment, when you apply square root both sides, you have two possibilities. N is equal, and we have a square root negative 9. Actually, we have no real solution. You thinking about the real numbers, but you're extending your idea for the complex. Oh yes, we have solution plus and minus, sorry, plus and minus. Because I know, okay, square root negative number is equal plus and minus the square root positive number multiplication by I. And square root 9 is 3, because it's plus and minus 3. So depending the question, si the question restricting the answer in the real field, okay, we have no solution. No. See the problem is standing in the complex. Okay, we have x1 is 3i is a pure imaginary number and negative 3i. This idea is clear or confused? Remember.
Clear.
Remember the square root of negative number is impossible to find the solution in the real. But the complex, yes. Okay, number 5 is parentheses 3x minus 2 squared minus 5 equals 0. We can expand the binomial square. You know, manipulate and write the equation in standard form, determine A, B, and C, and apply quadratic equation. This is one possibility. No, but however, I take advantage que somebody know me do the factorization of that part, and to say you apply one more time a square root property. How? Well, you isolate that part, que is a square, and move 5 to the other side. I apply a square root. Get the idea behind this square root property, square root method. Entonces, es obvio que 3x minus 2 stay without square and square root because cancel out each other. And in the right hand side, we have plus and minus. Don't forget this, please. Radical 5. And the rest is easy. It look like linear equation. 3x is equal to plus and minus radical 5. I move 2 to the other side, like a positive 2. You put in the first place or in the second, it doesn't matter. I prefer in the first place. And finally, divide by 3. Divide by 3. X is equal 2 plus or minus radical 5 over 3. Okay, the only problem is that the solution is irrational number. Irrational means it involves somehow a square root of the prime number. Therefore, we cannot represent like fractions. Well, fraction in the strictly common sense for the fraction, que is integer number divided by another integer number. In this case, no, integer is irrational. Okay, so basically we have two solutions, irrational. Okay, no problem. One is 2 plus radical 5 over 3, and another is 2 minus radical 5 over 3. Oh, either way, you express it using this symbol, plus or minus. Guys, this is equivalent. At least for me in the test on paper. And Alex, depende, ¿no? The Alex is a little bit picky, so you need to write both separated by a comma, maybe. Okay?
Yes, Professor. In Alex, we need to put both.
Yeah. So you need to understand it's the same idea. But, you complain, oh, Ale, great incorrect. Yes, Ale is a robot. But you don't worry, you inform me to me, anything that you know, I fix it, because I go to my secret way inside Alex, they say, Ale, no, this answer is correct. Okay, you need to be aware of that situation. I fix it. Okay. Okay, now. Number 6. Number 6 is the variable t, no? Parenthesis t plus 7 square equal negative 14. Okay. Okay, again, one more time, square root. Square root both sides. Square root both sides. T plus 7 equal, plus or minus. Don't forget plus or minus. And the quadratic formula, when you write the quadratic formula, you have plus and minus. And this plus and minus come from the same idea of the square root. But one more time, we have a square root negative number that says I square root 14, but 14, I suppose que it's impossible simplification because 14 is 2 and 7. We have no couple of factor. No. Okay, leave it like that, like a 14. Finally, t is equal minus 7 plus or minus I radical 14. Okay, we have two solutions. In this case, the solutions are complex. Okay, complex. Remember, the word complex comes from the combination real and imaginary. In this case, the complex number has real part and imaginary part. That is the reason it's complex. Okay, in this case, for example, no. In this case, real. And this no, this is purely imaginary. It's a particular case in which the real part is 0. So now the answer is minus 7 plus I radical 14 and minus 7 minus I radical 14, complex solution. Do you understand the idea? This is important, guys, because in the college algebra, we start the first lecture is a complex number in detail, more clear, more deep. Okay. Okay. No problema. Okay. Suppose que sí.
No.
No. Okay. See. Next page. I suppose que es this. Okay. In this case, well, we have find the value of such that expression is perfect quadrant. Oh, This is the, okay, let me try to explain. This is the completed square. Completed square, I don't explain that. I promise in college algebra I explain in detail again. But no problem, I try to explain. Now, it's super easy. Look, you have x squared minus ax plus something, okay, they call a in record. And the idea is completed square. What means to be completed square? Completed square means que this is binomial 1, 2, but I include one extra thing in order to convert to trinomial. Trinomial 1, 2, 3. And this new trinomial is perfect square. Perfect square means that you, when you are doing the factorization, instead of two parentheses, no, only one, because they are twin brothers, a square. This is perfect square. Perfect square trinomial. And this is regular trinomial. But what is the idea? The idea is I try to plug it in artificially. One new number here inside this question mark. That when you introduce artificially this number, now we have a perfect square trinomial. So what is the rule? The rule is you take b divided by 2 and a square. This is the formula. So you split 8, b is 8. So 8, you divide by 2, always divide by 2. Okay? Is 4. And the square is 16. So 8 divided by 2 is 4, and 4 squared is 16, and 16 is a number. And when you put here in this box, 16, now this trinomial is perfect square trinomial. We try. The factorization, suppose que no, que I don't know, I open two parentheses, but the combination is obvious, que 4 and 4, because 4 times 4 is 16, and 4 plus 4 is 8, and both negative. So not necessarily write like that, much better write like that, x minus 4 squared. You understand the idea of this procedure? Is called completed the square. Okay? Do you understand or not?
Yes.
That's easy. You divide by 2. You take b. Divided by 2. B, what is b? B is a linear term. In the quadratic equation, you have quadratic, linear, and constant. You take the coefficients in the linear part, que is 8. You divide by 2 and square. Boom. Who helped me in the second example? Que is x squared plus 7x plus something. What is the magic number que complete the square? Well, in this case, ugly, because 7 is no even number, and when you divide it by 2, I don't know, this example is they put this example to illustrate, not always say happy, no? You divide by 2, 7, and a square. You say 7 squared over 2 squared. 49 over 4. The magic number can complete the square is 49 over, and that's it. Well, you want to factorize? Okay, let's do it. I know the perfect square, only one parenthesis is square, and the square root this guy is 6, and the square root this guy is 7 over 2. And what sign plus? This sign is this sign. This sign is this sign. In this example, the sign inside the binomial after the factorization is the first, because the second always is positive. See, the second is negative, so it's no perfect square. It's a mandatory. The second sign is positive, and the other not positive or negative, depending on the problem. I don't know. You say, well, what is the application of this? Oh, the application of this is another way to solving the quadratic equation, que es using the completed square. I want to explain it there? No. Okay, there you go. Suppose this example, case number 3. X squared minus 6x plus 1 equals 0. Okay, our classical quadratic equation expressed in standard. The quadratic term, the linear, and the constant. And right hand side 0, elegant. You can put A, B, C, apply the quadratic formula, and you get the solution in 1 second. No, not 1 second, but fast. Another way is the organization. No quadratic equation, no quadratic. They want completed square. And this subject in intermediate algebra is totally optional. You using completed square or not. In college algebra, well, little bit because one question in the test is mandatory solving by this method. But it's okay. Look at the organization. The organization is pretty easy. You bring down x squared. You bring down 6x. You move 1 to the other side, like a minus 1. And you put a box. Okay, this magic box is a number I introduce artificially to complete a square. Okay. And remember the formula. The formula is b divided by 2 squared. And b in this example is 6. 6 divided by 2 is 3. And 3 squared is 9. So the magic number I need to put artificially to complete the square is 9. Cool. Now, I know can magically happen. Okay, this is perfect square trinomial and the factorization is x minus 3. Where come from these 3? Square root 9 is 3 and square root x squared is x. In the right hand side, we have 8. It's 9 minus 1. Cool? So now, I have elementary quadratic equation que I can solving using a square root method. Square root both sides. X minus 3 is equal plus or minus radical 8. Oh, let me analyze if A is possible simplification or not. A is even. A is equivalent 3, 2. Therefore, we have a couple of 2 can represent 1, 2 outside. Okay, nothing. So far, x minus 3 is equal plus or minus 2 radical 2. Is the simplification radical 8. Now, finally, x is equal 3 plus or minus 2 radical 2. And this is the answer. 3 plus or minus 2 radical 2. In the case, I practice using plus and minus. Okay, so now I recap again the idea. I find the magic number. I call this magic number. And this magic number allow us complete the square. Of course, I put artificially this magic number case not in the original equation. In order to keep the equilibrium of the equation, you put in the right and the left the same number. Because my equation is equivalent. Okay. Because you cancel out this 9 and this 9, but we are doing nothing. We come back at the beginning. No. I don't want this. Do this. Clear or confusing?
Clear.
Okay. I suppose que you don't like too much this, no? Pero this is the idea behind. So the quadratic equation, the famous quadratic equation, is, like a shortcut to condensing this completed square in one equation. Okay. So now, if you don't understand very well, So now you can apply quadratic equation, and you forgot, at least in this subject, a completed square. But you're using another thing in mathematics. Let's do number 4. Number 4 is x squared plus 2x plus 2 equals 0. Okay, I need to solve them by the same way. The same way. So you bring down x squared, bring down 2x. I'm moving the constant always, because the constant original is not perfect square. No. So now I put -2 and you put the artificial number. That complete the square. It's obvious. In this case, you take b get 2, b over 2 as the formula square. In our specific example is 2 over 2 squared. So 2 of 1, 2 1 square 1. Is 1. 1 here and 1 here. So now this trinomial perfect square, and the factorization is only one parenthesis. In the right hand side, we have -1. -2 and 1 together is -1. Okay, now I am ready to apply a square root method, similar to the other page. Square root here and square root here. X plus 1 more time happen, get square power and square root cancel out each other. And now we have, unfortunately, a negative number inside the radical is imaginary. In this case, just I. Because the definition, no? The I is, by definition, is square root -1. Do you understand that this is a symbolic way? So actually, in the real life, it's square root -1. But everyone in the world call I. Okay? Now, finally, x is equal -1 plus or minus I. This is the answer. 1, -1 plus or minus I. Any question? No? Super clear, complete square, or no? Confusing. You lie or you don't lie? No, no answer.
I like it.
Yeah, pero you prefer quadratic formula, no? Or no?
No, both.
Both, okay. Okay, let's do one more. Let's say x squared plus 16x minus 3 equal to 0. Same idea. You bring down x squared, you bring down 16, you move 3 to the other side, and you put 2 boxes, and inside each boxes we put the magic number that completed the square, the trinomial, and the left hand side. And the formula is b over 2 squared. Like our specific example, b is 16. 16 over 2 squared. 16 over 2 is 8, and a squared is 64. This is the magic number, 64, 64. Okay, now this trinomial is perfect square. Nice. We enforce that situation. We create that situation. Now we have only one parenthesis square. X gets a square root of this guy, and the square root of this guy is 8. This side is this side. And here we have 67. Okay, no problem. Now, ready to apply square root. Both sides. Again happen, k square root and square power cancel out each other. And we have square root 67. By the way, guys, 67 is prime number. We cannot do anything. It's plus or minus radical 67. It's irrational. Therefore, the solution is -8. I move 8 to the right, plus or minus radical 67. Negative 8 plus or minus radical 67. Irrational solution. It's a complex. It's a real, but irrational. And this is also real irrational. Cool. Okay, no problem. You can erase.
Yes.
Okay, cool. Let me try now. Okay. The next page is this one. Okay. Now, day one. Can you solve the quadratic equation using the quadratic formula? Yes, this in red color. So in blue color, you see the quadratic equation definition expressed in nice standard. And here you see the quadratic formula can help me to solving the quadratic, any quadratic. Definitely, okay, this is the best way, the more powerful way, because the factorization is weak. Sometimes you don't see the combination, or sometimes it's impossible to see the combination because it's irrational solution. Nobody can do that by factorization. The factorization is nice. You are doing too fast, but not always happy, not always work. Okay, so now I take advantage. 3x squared plus 2x minus a equal to 0. Wow, I like that. This equation is nice because it's expressed in standard. Expressed in standard, then I can identification quickly who is A, B, and C. A is 3, B is 2, and C is negative. And again, one more time, I copy in my paper, one problem by problem, the quadratic formula, because I need to memorize this. Using in college algebra every day, quadratic, from the first day, I promise, to the last day, in December. We start October, in December we continue doing quadratic formula, quadratic formula, quadratic formula every day. Now substitution. Plugging in, plugging in, plugging in, plugging in. Es minus b, que es minus 2. In this example, plus or minus square root 2 squared minus 4 multiplication by 3, que es a, multiplication by negative a. Be careful with the sign. The sign is extremely important. 2 times 3. Look, this is my way. I try to explain anytime. You copy the formula. You just substitution, plugging in into the formula, but don't do any operation. No. So you are doing operation, substitution, operation. You confusing, maybe. So now systematic way, you substitute, you replace the variable A, B, and C by the corresponding value. Now, this is a crucial moment in which you are focusing and the expression inside the radical, que is the most important no, is the, according to the order of operation is this. This is 2 squared get 4. And this is plus. How do you know get plus? Minus, minus, 2 minus, right? And you multiply. You multiply 4 times 3 is 12, and 12 times 8 is 12 times 8, 96. Plus 4 is 100. And a square root, the formula have a square root after that. Now the order of operation is u square b. You multiply 4ac, subtraction, or addition, depending the size. Now, you apply square root 10. Now we have so far minus 2 plus or minus 10 over 6, que es the multiplication 2 times 3. Okay, personally, I like so much, okay, because it's confusing, at least for me, this sign. So I separate into problem, one positive and one negative. Okay, entonces es 10 minus 2 is 8 over 6. We can still reduce and lowest term. It's obvious because 8 and 6 is even number, divided by 2 is 4, divided by 2 is 3. My first solution. And here is minus 12 over 6, que es negative 12. Done. So we have two solutions. Como frequently happen in the quadratic equation. 4 over 3 and negative 2. X equal 4 over 3 and negative 2. Two solutions because that function is a parabola. And the parabola maybe cross it, maybe no, for sure, cross it, the x-axis into value. Okay. Any question? No? Are you feel strong in the quadratic formula? Tell me, guy. And this is easy, this chapter or no? It's easy, but it's crucial. Yeah, Emily. It's easy, but it's crucial. So it's super, super important, super, super important. Not only in this class, in the future, in algebra, quadratic equation. Okay, one more. Number 2 is 4x squared plus 5x plus 1 minus 1 equal to 0. Ready, standard to determine A is 4, B is 5, and C is negative 1. Okay, now I copy my formula. Look, I want to see in the test something like that. Any problem, you copy the formula. The organization is extremely important in mathematics. Now replace. Don't do anything. Only replace. Minus 5 plus and minus square root 5 squared minus 4 multiplication by 4, que is A, and multiplication by negative 1, que is C, divided by 2 times 4. Okay, now focus C in the expression inside the radical. Don't do anything, only the expression inside the radical. Here. This is 25. Guys, I recommend doing this way. And you are doing, you imitate my work. You put the line or the arrow, whatever, and you put this equivalent 25. And this is plus. How do you not get plus? Because negative and negative together is positive. 16, no? Because it's 25. 4 times 4 is 16 times 1 is positive 16. Now 25 plus 16 is 41. Ooh. And 41 is prime number. Okay. Therefore, we cannot simplification. We cannot. So it's negative 5. So minus radical 41 divided by 8. Okay, is the multiplication 2 and 4. And 41 is prime number. So we cannot do anything more. No more. Leave it like that. We are x is equal negative 5 plus or minus radical 41 over 8. But this is irrational. It's real irrational solution. Equation. No? Okay, cool.
No, Professor.
I propose you do number 3, and that's it for today. The other package we are doing Wednesday, okay? I am so proud of this class. These classes are doing very, very well. Some complications, but not too much. Of course, I drop the student doing nothing in the second test. Now I suppose the student can stay, finish. Okay, so now x squared minus 10x plus 29. Wow, that's weird. Equal to 0. A is 1. B is minus 10. Be careful with the sign. And C is 29. Remember, the supposition is que the standard is ax squared plus bx plus c equals 0. And when you compare these are these, it's obvious that a is 1, invisible. B is negative 10 because the supposition is that every coefficient are positive. See, you see in our particular example that one guy is negative, it's because the coefficient is negative value, negative 10. Okay, ready. I copy my formula, as always. I substitution. Okay, be careful. Again, the sign. B is negative. However, the formula have a minus, double negative, double negative. If you want to put double negative, personally, I don't like. You see that situation, I know very well that double negative become positive, no? There are no reason to write this long. So 10 plus or minus square root negative 10 squared minus 4 multiplication by a que 1. 1 is invisible factor, and 29. Que sí, positive. Divided by 2 times 1. Okay. Okay, now I go directly to the expression inside the radical. And the expression inside the radical, this is 100 positive. Now I copy 4 multiplied by 1 to 4 times 29 is 100, but negative 60. And when you subtract each other, it's negative 60. And when you apply square root both sides, again, we have complex, or not exactly complex, a pure imaginary number. And this is I square root 16 positive. Okay, so far we have 10 plus or minus for I divided by 2. Okay, now separate. 10, well, separate, no. Ahí the best way is you factorization, maybe. In the top, the greater common factor is 2. And we have 5 plus or minus 2 items divided by 2. Oh, and this 2 is canceled. And the final answer is 5 plus or minus 2i, is a complex number. The real part is 5 and the imaginary part is 2i. Solution is 5 plus or minus 2i. X equal 5 plus or minus 2i. Okay. So now we stop here. So far, we're doing well today. And remember, in short minutes, when I create the video, no, because the video have a process, I send and resend again the actual test number 5 and the final test. Okay, just in case, you know, the test have a name, test 5, test 4, no, test 4 is history. Okay, guys, entonces, bye-bye. Have a nice day, everyone.
Bye, Professor. Thank you.
My pleasure, anytime.